the last module we looked at the basics of lighting, that is the indices which are used in lighting like illuminance, luminance, a few parameters we looked at. In this section we will look at design concepts, how you can harvest daylighting. So, primarily we will look at daylight harnessing systems. There are two types, harnessing and harvesting systems. We will look at specific types and few products which are available. Then we will look at what are the typical design considerations for harnessing daylight. Typically we know that daylight is very effective, efficient as well as more realistic form of light. You get the actual color rendition of a particular object. Any object seen in natural daylight is more realistic than rendering it with artificial lighting. It is more energy extensive if you have to really render it to the actual color of it. So, typically we have been studying about various methods, or logically we know that various methods of effectively getting natural light into the building. Instead of having single large panel windows, for example, you can have two clear sets of windows glazing, one catering to the work area close to the periphery, the other the typical skylight or the top the top part of the thing can be split, which will throw light onto the interiors of the building or the core areas of the building. The other simple option is, instead of having linear horizontal elements, you can have vertical, where you have a better throw of light far to the core areas of the building. Other ways include provision of louvers, provision of skylights, clear stories, north lighting, roof trusses, industry lighting. See, look at this, this is a naturally lit, apart from simple specific lit lighting which is just used for a backup. There are certain lights which are still there, seen there, but primary amount of light which you receive here is daylight, well lit on both the surfaces. It uses all the possible daylight harvesting techniques so as to provide more or less uniform lighting across the work area. Different types of harnessing as well as harvesting daylight. First is, as we looked at, effective design of fenestrations. So, we have to take an account of what type of fenestration, what glass if it is present, what type of glass we are using, what type of reflections, re-reflections, diffusions we are using, what strategy specifically we are adapting in the fenestration design. First is design of fenestrations. Second is use of daylight harnessing systems. What are the specific things where you can improve or enhance the amount of daylight available. So, you have specific harnessing systems with which are strategies adapting which you will be able to improve direct as well as diffuse light which is entering the building. Third thing is specific systems like harvesting systems which are used even to remote part of the building, core areas, dark areas, even to the basements for example. You will be able to transport and get specific amount of illumination which is required. We will take a look at the details of systems which are available. Daylight harnessing systems, typically there are two types, one is with shading, other is without shading. The one with shading, daylighting system, harnessing system with shading, they primarily rely on diffuse skylight and reject the direct skylight which is available. There are also systems that use primarily direct sunlight which will reflect or send it into the locations which are above the eye height. For example, there are this particular system will diffuse the light and reflect back the direct light. The second type of system will like light shelf. We will look at the details further. There is a reflective part which is getting direct light and reflecting it into the ceiling. It is not allowing it to affect your eye level, whereas it is reflecting into the ceiling or the interiors of the building to get further re-reflection, light the core part of your space. Second type is daylight system without shading. Here you have diffuse light guiding system and direct light guiding system. Third type is light scattering or diffusing system. Mainly they are used in top lit apertures. They are primarily light scattering systems. If you are trying to use it in windows, they will cause glare. Excess amount of diffuse light will be available. Primarily they are used in skylights or on the top clear stories. Then you have light transport system which we will take a closer look at. Simple example of light reflecting system shades, you have light shelf, very commonly used. It can be active, it can be passive. You have conventional and optically treated light shelves available. It works on a simple phenomena. You split the whole glazing or window area into two. The first part it caters to the peripheral areas directly. Then you have, it can be also attached and used as a shading system. It shades this particular glazing area from direct sunlight it improves the energy performance of your window. Then you have additional advantage, if the top surface is reflective, it will get direct light reflected back here and then it will re-reflect it to the interior parts of it. It can also be optically treated. Say for example, different times of the day, winter sun versus summer sun. Winter sun is very low, you get light directly in. Summer sun is very high, it gets reflected from this and caters here. Some of these things are also adjustable, it can be upward or low, downward tiltable depending on the requirement. Like you say in this example, it can also incorporate a specific manual or automatic tilting facility so as to adjust the amount of lighting which is required in a particular space. It works, as I said, in a simple principle. It can extend into the building. If it extends further, the amount of light penetration will be much higher, whereas if you are closing it up to this, it is a simple shading device which is only used, the interior projection is not available, then it will only reflect to specific areas, the further interiors will not be lit very well. Of course, there are other associated things I will talk about in a moment. Summer sun is high, you get directly into the interiors, not into the core, they are not much lit, whereas winter sun is directly falling on the low winter sun, you will get direct skylight, whereas summer sun it will reflect into the building. There are other considerations. For example, one of the projects we ended up giving a nice light shelf, as we predicted or as we calculated, the performance was also good, interiors were well lit, but there was a problem of the rainfall which was causing noise. This was a simple double glass which was provided here. There was it was a high rainy area, there was a high rainfall which is falling on it, the raindrop was creating excessive noise level into the interior. Then we have to also take care of soundproofing, we have to take care of waterproofing. There are other things associated while designing light shelf. It is not a simple insertion of a panel, there are associated factors which has to be taken into consideration. A simple graph which says without this light shelf, the light level will be very high here, daylight level or light factor, daylight factor would be very high, eventually it will drop down. If you have only exterior shelf, if this portion is not existing, only external shading kind of, then the light level will be very high here, eventually it will drop down. If you are also increasing it from exterior to interior, like I said there, if this is extending into the building, then it is not excessively lit here, while the interiors are also fairly getting improved amount of lighting levels. It is also not right practice to get excessive amount of light in the periphery and making it too darker in the interior. So ideally this type of light shelf extending into the interior of the building will have a fair distribution, at least for 2/3 of the room area. Depends on the fenestration size and the depth of the system itself. Typical example of light shelves, you can closely look at it, they are projected inside without any artificial lighting, you get the desired amount of light which is available. Again here it is getting reflected to the ceiling, getting back to the workplace. Without artificial light they are able to perform typical office activity. The second type is use of louvers and blind system. Different subdivisions are there, fixed and operable louvers as well as blinds. You have translucent blinds and you have light directing louvers. It can be used separately as a component or they can be tagged to window elements itself. Some of these cases they are made part of the double glazing unit. Some of them are placed inside double glass unit where between the two panes inside the air gap. So they also act as light reflectors. Some of the examples, for example, these are reflective louvers placed in between two panes of glass. They reflect and re-reflect light into the interiors. You also have fish system, for example, they are another type of reflections where the light falling on it gets scattered and then you are getting more diffuse reflections focused into the particular space. Another concept which is in use is called prismatic panels. These are typically acrylic panels which are cut and each one of it acts as a prism and backing, and the angle, the shape of it and the angle of it, the size of it determines the reflection which is happening into it. They are mostly inserted into double glass units like we saw in the previous case. Between two panes these are inserted and what happens, this will reflect and diffuse the direct light which is falling on it. Different types are there. Simple diffuse daylight, they are normally used in vertical plane facades to redirect light from outside the sky and it will be reflected into the inside the room. typically on the ceiling surfaces, the light, direct light will fall, these prisms will reflect, these are typically placed inside the window or glazing systems. There is another type which is sunlit, they can be used to get or direct the direct sunlight, the natural light into the room. If you are wanting to use it on the vertical surface, typically these are used on skylights, if you are wanting to use it on vertical surfaces, they may cause glare, so it is better to closely look at or work upon the type of profile, and it is also better idea to give seasonal tilting of panels so as to avoid any glare related discomfort. The other types include fixed sun shading system, they can be used as typically they are seen in glazed roof, they can track the movement of the sun, automatically move, or they can be adjusted, or sometimes they are integrated into double glazing unit. There are also movable sun shading system where they are placed in front of double glazing system or behind it or sometimes inside it, they also act as sun shading devices. One of the emerging things which is lot of research is being conducted in this type of system, they are also in the market, some products are available, these are laser cut panels, they are typical arrays are cut within typical rectangular arrays are cut. Main advantage here is they are able to give you unaffected or less affected views, the views are being maintained, so the glass itself is like a see through glass, you do not have any concerns about it, but still it is able to reflect or deflect through a very large angle. It also gives you flexibility of manufacturing in small or large quantities. Apart from this, you have light guiding shades, simple devices which can specifically reflect and re-reflect. The primary concept with any of these devices is either it cuts the direct light, diffuses or gets only the diffuse light, or diffuses the light itself into the building, or there are systems which will reflect the direct light into the interiors of the building. Periphery anyway is getting well lit, the main idea is to transit or pass through this reflections into the core or interiors of the building, which typically is a comparatively or relatively darker area compared to the periphery. So this is another type, light guiding shades, which the radius and the curvature of it versus the tilt of it determines where it is getting actually reflected. Apart from this, you have deflecting panels, vertical as well as horizontal deflections can happen. There are many such types of, more than this there are also other varieties, these are some common things which are in the field. Let us take a look at specific guidelines for designing skylights. If you are wanting to put these skylights into your building, simple example, you can distribute them evenly so that you will get more uniform light across your space. Second idea is you can have certain splayed edges so that instead of sharp edges, if you have splays here, the distribution will be much more wider. Then you can place them near the wall, if the wall surface is reflective you will get good amount of reflection, or you can place certain reflective panels so that they get reflected and re-reflected. Some examples for for instance, there is a skylight on top, here they have used reflectors, now the light is incident, it is getting reflected back and then it is lighting the space. Apart from this, you can also notice they have certain supplementary lights, when daylight is less or it is not available, then these lights can be turned on. This is another type where they have tried to employ daylighting, again here only few of the artificial lights are on, still they are able to manage a dramatic interior with good amount of visibility. We have been looking at harnessing systems, light pipes, which is also another emerging technology. There are also commercial products which are available, which you can simply buy and assemble and fix it in your building. Light pipes which are typically daylight harvesting system, there is a unit, it can be dome or pyramidal shape, or there are different types available in that. They will typically cultivate or harvest daylight on your rooftop or any outside surface, and they will transport it to the interiors of your building. Three components are there. First is there is a receiving element, then there is a transitional portion which will have to have good reflecting surfaces so that the light is simply reflected, the losses are less. Then you will have a final internal component which acts as your light source. Lot of buildings have tried using this for dark basement areas, where instead of artificial lighting you can have it in your gardens, from which the light is harvested and put into your interiors. Lot of energy savings can be attained, but there is a major concern here, the sky lighting gets fluctuated when there is cloud movement, there is a dark sky, there is a bright sky. By virtue of this, the amount of light which is varying, which is received inside highly is fluctuating. In that case, you will always need a supplementary light whenever there is a dearth or reduction in the amount of daylight which is available here. This supplementary lighting, there will be a sensor which measures the amount of light which is getting through. If the light levels are lesser, this will be actuated, this light will supplement the amount, so that interior suddenly do not turn darker and you do not lose vision in that case particularly. For example, you have a basement parking, you definitely need specific set of backup lights. There should be a sensor and actuator mechanism which will sense the amount of light coming in, it will actuate the artificial light. So whenever there is a less amount of light which is received, this will get activated and you will have artificial light, interior light levels or lux levels does not get drastically affected. There are also certain other methods like vanes or dampers which are available. When there is excessive amount of light, you can control them so that you have a constant amount of light. Say you only need 300 lux, when there is excessive amount of light, these dampers or vanes can tilt and minimize the amount of light which is coming in, so that they can be maintained somewhere between 250 to 350 lux. There is a range within which it can be maintained. The other technology which is in practice in some of the places, it is slightly pricey, so it is not widely available in market, but as a technology it has been proven. Once the cost like LEDs, once say 8-10 years back LEDs were too costly, now every house tries to buy LED lights, it has become very cheap, cost effective method as well, the prices have drastically come down. Right now light tubes, these transport light through them without much of losses, they have very thin slender fibers, there is a almost zero reduction in terms of reflection losses, the light is transmitted through them. So you have a receiver or a harvesting mechanism, you can have it facing the sun, this will be receiving the daylight, it will be reflected and passed through these optical fibers. These are typically optical fibers called light tubes. This will transmit this and then through the fiber optic cables it will be lighting your interiors. Simple mechanism, but it is slightly, as I said it is slightly expensive in the current day, so the technology is eventually picking up, but as such it is a very good harvesting system which is technically proven. It can be easily tracked to other light controls and actuating devices, so supplementary artificial lights can act in tandem with this so as to maintain a uniform indoor lighting. When we talked about sensing and actuating, any type of daylight harvesting system like say light tube or light pipes will require a backup artificial lighting control. So in this there are two types, typically there is a sensor which is capturing the amount of light which is falling on it, essentially the lux levels are measured, then it is trying to give the signal to or actuate to the actuator which will be controlling the artificial light. There are two types here, one is open loop and other is a closed loop. Open loop system measures only the natural light and then it does not consider the electric light contribution. In the closed loop system it is measuring the combined contribution from natural and artificial lighting system. There are two different types of lighting control systems, one is a switch based or switching daylight control system, other is a dimming daylight control system. Switching is working, it is a simple binary logic, it is 0 or 1. So you have a threshold of 300 lux which is required inside a classroom or an office space. You set this limit to a switching control. There will be a small buffer which is given. It can be 20 or 25 lux. So if you say 20 lux, when the light levels fall below 280, instead of 300 there will be a buffer up to 280. Once it is below 280, the artificial lights will be turned on. Whereas in the dimming control there is a provision for adjusting, increasing or decreasing the light levels. Initially with our conventional lighting system like incandescent and CFL lights, there was a problem of wear and tear and the light fixtures getting worn away very easily. There was with LED lights the dimming controls have become more seamless because the life of these LED systems are very long, they work very easily with the dimming controls. There are three things associated which we have to understand. First is a dead band, it essentially represents a threshold beyond which or below which the actuation actually happens. Then there is a delay time. For example, there is a cloud passage, suddenly the sky gets dark for a moment and then it's it is reverting back to original. You are actually having 8000 to 10,000 lux, suddenly there is a cloud, dark cloud which is passing by. So you have a very small amount of instance of time within which the light level drops and then it comes in. So you work around with the dead band and delay time, so that the sensors and actuators are not very constantly turning on, turning off, or dimming, increasing or brightening, dimming or brightening the internal lights. Then there is a fade time. For example, how much time it takes for the light, it is a curve, how much time it takes for the lights to fade away or to start with, it is a dimming, so it has to turn bright, how much time it takes, whether that is suitable for a specific task. For example, if you are working on a very sophisticated thing, you do not have the provision to lose even for a fraction of second the required amount of light level, then the fade time should be very low, it should immediately turn on to supplement you. Or if it is like a general office work or household things, the fade time can be slightly longer. All these three things will affect your efficiency or energy consumption of your overall lighting system. So there are two components we have to keep in mind. One is effective daylight harnessing or harvesting, and second is the use of control system, which is also crucial. The type of control which we are tagging to the actual artificial lighting will also determine the efficiency or energy performance of your whole system. That actually determines your daylight efficiency and the reduction in artificial lighting energy. So in this session we looked at two main things. One is we talked about daylighting design, we continued with the daylight factor which we stopped in the previous module. We talked about daylight harnessing system, we looked at daylight harvesting things like light pipes and light tubes. Then we also looked at certain design considerations for skylights apart from the type of controls which are available. With this we are closing the whole program. So far we have been looked at the thermal, acoustical as well as lighting part of building science. So now I wish you all the best for your exams. Thank you.